Okay, so the test on this stuff is coming up next week on Wednesday. We've covered most of the stuff you need to know, but there's a few more things that you got to know how to do. Let's talk about what the stuff we've already learned, and hopefully this is the stuff you already get. What's that? Starting value. What's that? It's got a word that starts with a B, the base. And it tells you it's either growth or decay, and in this case it's what percent growth? 19% growth. All right. What if this had been written as 79 over 62 in there? How the heck would you tell what percent growth that was? Well, you divide them on a calculator and you get the decimal. And what if the decimal comes out to like 2.4? So let's say it came out like this. Y equals 7, 2.4 to the x. Is that 140% growth, or is that 240% growth? Or what is that? Is it 40% growth? All right, we need to figure this out. This could be written as 1 plus or minus, and it's plus 1.4. That tells me the 1 is just brings back the number that's in front. 7 times 1 is 7. I didn't grow at all. This is the growth part. So 2.4 really means it's growth of 1.4, which is what percent? 140% growth. All right. This one is clearly not growth, it is decay. And you could write this as 1 minus something. What? 0.25. You see how if you write it as 1 plus something or 1 minus something, you can tell what the growth rate is? So this is 25% decay. All right. Now, this one also has something tricky built into it. If I were to ask you, what's the starting value? What is it? It's not 3. It's 7. Why? Because the starting is where you'd start plus wherever you'd move to. That moves up 4, so it'd be 3 plus the 4 makes 7. Here's another way to say it. What's the starting value? It's the y-intercept. See how it's the y-intercept? The y-intercept is where what? X equals 0. If I stick in an x is 0, you see how this turns into a 1? And now it's 3 times 1 plus 4. The answer is 7. This has a starting value of 7. Do you get that? Are you going to let them fool you on that on the test? Good. All right. So it's not a starting value of 3, it's a starting value of 7. All right, next thing. If you had one like this that was written with like y equals 4 times 2.7 to the x, is that exponential? Because it's got a x in the exponent. And there's not an exponent in the base. You can't have an x like here. That'd be bad. All right, so then what percent growth is it? I strongly recommend you think of each of these as a 1 plus or a 1 minus. In this case, it would be 1 plus what? 1 plus 1.7. So what percent growth is that? 170% growth. Okay, got to move the decimal over a couple spots to see that. 170% growth. All right, moving on. Another trick question. What's the starting value? Well, the starting value is normally here, but we got to also watch out for that. And then what's that thing I was saying about this? Well, the starting value is the y-intercept. The y-intercept is where x is 0. So the simplest thing to do is just stick in x is 0 right here. What's negative 0? Well, it's just 0, right? So then what's 6 to the 0? That's just 1. So what's the answer? 5 plus 8, which is 13. So starting value is 13. Raise your hand if you get that. Okay, good. Then, what's the growth or decay rate? Be careful. We've never had a negative up here when we've been describing whether it's growth or decay. Normally I would have said, oh, well, it's growth and it's 500% growth. But it's not. Why not? Well, because there's a negative up there. What does that mean? Do you remember how that means that this 6 right here could be written as 1/6 if you flipped it, right? This negative means I could rewrite this equation as 5 times to the positive x plus 8. Now it's written with a positive x. Now you could tell me, is this growth or decay? It's decay. If I needed to know decimals, it might be easier. I just divide 1 divided by 6. It comes out to 0.16, which is one of the only times that ever happens. So if it's 0.16, it's like 0.84. So it's about 84% decay. You see what I just did there? I rewrote this as this so that it had a positive exponent, so then I could see whether it's growth or decay or not. Whether it's growth or decay. All right. Would you please try to rewrite that one so that it has a positive exponent? So then you'll be able to tell if it's growth or decay. Well, when it was a 6, I made it into a 1/6. What do I do with the 2/3? I flip it and I call it 3 over 2. And then it's to the x. And now, is it growth or decay? It's growth. What percent growth? 50%. And if you can't tell that, you should write it as a decimal. And it's a lot easier to tell that it's 50% growth. Are you processing this? All right, one little step at a time. You'll learn a couple more little things. All right, how about this? What if I tell you the starting value and one other point? By now you should be like a rock star at this. Y equals a, b to the x. Stick in the a as the starting value. Put a 4 there. Put in the other points and solve for it. Go for it right now. Do it from beginning to end. You'll need a calculator because there's a divide in here that's really nasty. You are welcome to borrow one of mine if you'd like. Here's another one. Anybody else need calc? Need calc? There you go. All right, so the y is 8.05, and the x is 5. And so I've got 8.05 equals 4b to the 5th. Then I divide by 4. I'm going to need some help on that one because I can't do that in my head. Would you tell me what 8.05 divided by 4 is? 0.125, thank you. And it equals b to the 5th. Now, you're confronted with this little thing. How do you fix that again? Put it to the 1/5. All right. So then, when I put this to the 1/5 power, this becomes just b, or b to the 1, but that's just b. And then this one, I am guaranteeing that if I have all of you type this into your calculator, at least 2 people will get the wrong answer. Because I know you're going to goof something up. I even told last class how to type it in. Still had people goofing it up. So I'm going to try not telling you and see if you can type that in yourself and see what you get for a decimal. Just try it. We'll see if you do it the right way. See if your natural instincts are correct on this one. So you check with the smart kid and see if you did it right. All right. All right, so you seem pretty confident now, so what do you think? 1.15, blah, blah, blah. Okay, good. Now, I'm not going to embarrass you, but I know that there are people that will have not had the right answer there. Can you tell me what you think they probably did wrong? What do you need to do it right? Parentheses. If you don't put parentheses around this, when you put it in, it'll not work right. Well, it actually depends on the calculator. If you got a certain mode, you might be able to make it work right. But 2.0125, power of, parenthesis, 1/5, parenthesis. Those parentheses are key because otherwise your calculator thinks you want to put it to the power of 1 and then divide the whole thing by 5, which is totally different than putting it to the power of 1/5. Okay, so don't forget the parentheses. I'd hate to have you get the problem wrong because of that. All right, so final answer is y equals ab to the x. But what's a? In this problem, what's A? 4. B is, we just figured that out right there, 1.15 to the x. Can you see that we've got a nice growth rate? What growth rate was it? 15% growth. Started at 4. All right. Moving on. I think you'd be able to handle this. It's the same thing. Don't even try it because we've done enough of these by now. But do you get that that would be the same as 2.5? So if you have trouble with fractions, you could just change that to a 2.5 and it would work. All right. Moving on. Describe the end behavior with limit notation. This is one of those kind that is got a limit. It's one of those, it's called a basic logistic function. And it is growing until it hits m, and in fact it never will hit m. It can't get to m. As soon as it hits m, then the world has ended. All right, so how do I write this limit? Well, any limit, you write lim of the function as x approaches, and you have an equals. Go ahead and do that. And tell me the left end limit. The left end. Technically, I should be saying the left end behavior using limit notation. All right, if you know this kind of function, you should know that it always has an asymptote right there, which means that it always, if you go far enough this way, you're talking about x going to negative infinity and it equaling 0. Raise your hand if you had that one right. Good. Okay. Then how could I change this to do the right end? Well, then you're not going to negative infinity. The right end is like way over there, and that's positive infinity. And how high does it get? M. May feel weird to write a letter there, but that's the right answer. Got to get used to abstract answers. Yes?
So when you're writing something, do you not actually write limit negative?
Oh, that's only if you have an asymptote that's like this, that you approach it from the left or from the right. If you're approaching an end, you can only approach that from one way. Know what I mean? I can't approach that end way down there from the other side of that end. It doesn't make any sense. Okay, so you don't need that. The little plus minus thing, that wouldn't make any sense in this context. Okay, that would only make sense if you had an asymptote line in the middle. All right, moving on. Describe this one with limit notation. Well, first of all, let's make sure you get what it looks like. This is one of those basic logistic graphs. Generally speaking, they all look like this. But this is different for each problem. And so how high it goes is different for each problem. Make a little sketch and label it for me. From the numbers I just gave you, you should know a bunch of stuff. All right. Hopefully you knew that 350 million is the top. Maybe this is like how many zebras Africa can support. That's like the max number of zebras, otherwise they'll run out of food. Okay, how about that? It's a start. I don't know if you know that, but this is the same exact thing as that AB to the X deal that we had before. So that's the start. And that means this is 4. And in my zebra question, it would be like you start with 4 zebras and you give them no competitors, no hunters, and they just frolic and eat and more frolicking, and then there's more zebras. Eventually you get 350 million of them.
Wait, wouldn't the starting value be 5?
Good question. If you, the starting value is where x is 0, right? Okay. But in this case, if you put in a 0, that's not going to be a great way to do this, because if I put in a 0 right here, then this becomes a 1, and this becomes 4 plus 1 is 5. And then we have to take 350 million divided by 5. So don't do it that way. On this kind of problem, for right now, just assume this right here is your starting value. Yes?
Isn't
It's a good question, really is. I'm going to have to think about it more, but I know. I looked at that too, and it really annoyed me. I was like, doesn't this mean that it should be shrinking? And this is growing. But here's what I figured out. On the top, see those other equations are on the top. A, b to the x, they're on the top of their fraction. This is on the bottom. So it's like the opposite. You know what I mean? You know how like when you divide by a number, if you divide by like 5, it makes your answer smaller. But if you divide by 0.5, it makes your answer bigger. You get what I'm saying? So we want this to be a decimal. So don't worry about that as far as growth rate. You're not going to be asked that. Well, I'm going to go with 29, but I am not positive. I'll tell you what we are going to have to know how to do on these questions, though. That is, if they give you 2 points, you can figure out all the rest of the numbers that are supposed to go into the equation. All right, so I'd like to do that with this one. This is just like the other kind. You know what? You've done this like 10 times now. You had straight lines where they'd give you 2 points, 2 comma 7 and 5 comma 9, and you put it into y minus y sub 1 equals m times x minus x sub 1. You did it with quadratics where they'd have at the bottom the vertex and any other point, and you'd put it into y equals a times x minus h squared plus k. Remember that? And then we just got done doing them with this, y equals a b to the x. They give you 2 points, starting value, and any other point goes here and here. Okay, but now I got to do one more kind of those. It makes sense that you could do it with this kind of function too. Yes? You're going to use the 1 in your equation. Let's just do this one together. You'll see. All right, so on this one, I'm going to call this 1.5, even though I know it might be off a smidge. I'd rather call it 1.5 than 1.6. Okay? So we're going to put that in as a starting value. We're going to say this gets up to 5 as its max. Would you please sketch that graph for yourself? You want one nice one like this in your notes. This is an important kind of problem. Worthy of another star. I only say that about on average once a day. All right, so next thing I'm going to do is plug in points into this. So f of x is like y. I could just say f of x and it would have been fine. The limit is 5. I'm going to put a 5 on top. Over 1 plus the a is the starting value, and that's 1.5. b to the x. Now notice I left an x and a y. No problem. Do you want a Kleenex to go on? Okay. All right. You want a x and a y in your equation only because I can then find another point on here. And this one happens to go right perfectly through that, which is at 3 comma 4. You see how that can be my other point? All right, so I'm going to put in 3 and 4. And now I can solve this puppy for b. All right, this is getting intense. This is pre-calc. This is not supposed to be an easy class. All right, so leave yourself plenty of room underneath this. If you're running out of room at the bottom of your paper, you might want to start copying it over again to make enough room. I'm just going to get rid of this stuff so I got room. All right. So now, my first thought is, if I have to get the b to the third alone, it's really annoying that I've got this big fraction. How can you get rid of a fraction? Multiply through by the denominator. Whatever's down here, I can multiply by that, and it'll get rid of my fraction. So I'm going to multiply by 1 plus 1.5b cubed, and multiply by 1 plus 1.5b cubed. And then this will cancel this. And now I've got 4 times 1 plus 1.5b cubed equals 5. Now, already it looks a lot better to me because it doesn't have a fraction. But I need to now multiply it out. 4 times the 1, 4. 4 times that. Now, some people make a mistake of thinking they have to multiply that like twice in there or something because there's like 2 parts to it. But this is all just one term. So I go 4 times the 1.5 would give me 6 b cubed equals 5. Now what? Subtract 4. 6b cubed equals 5 minus 4 is 1. B cubed equals 1/6. I'm getting really close. How do I finish this thing? Put it to the power of, that's how you get rid of a 3, is put it to the 1/3 power. Definitely a case of the calculator coming in handy. 1/6 to the 1/3 power. Grab the calculator, type it in, see if you're one of the people who gets it right this time. I'm going to have you show yours to somebody else, so make sure you've got it in your calculator. 1/6 to the 1/3 power. All right, these 2 rows, show the person across from you, or tell them that you weren't able to figure it out. Your 2 rows, show the person across from you, see if you got the same thing as them. Your 2 rows, show the person across from you. All right, good. If you don't know how to do it, figure it out. You do need to know this. All right, by the way, what was it? 1 point. Oh, it's 0.5, what? 50, blah, blah, blah. Okay, good enough. 0.550. So now, yes, sir?
We have divided both sides by 4 instead of distributing it out.
Yes, you could have. Up here, we could have divided both sides by 4. That would have actually been faster. I think you're right. It's still going to get the same answer, though. All right, so 0.550 is the B, so then I'm going to go back up here and say, all right, I really wanted to get one of these guys, and I just figured out B. That goes here. I already knew the A was 1.5, and now I can rewrite this thing. I can put in what I know. Y equals, the limit was 5, over 1 plus, the start was about 1.5, and then the B was 0.55 to the x. There we go. You get that? So we just figured out a logistic equation from its graph. So if I were to type this into my calculator, I would get this. At least I hope you do. All right. Any questions about that? All right, I'm going to pause for a second here. All right, so moving on. We are looking at one more kind of thing. What if they ask you an application question and you're not sure if they're talking about a population question, or which would be like one of these kind of graphs, or if they're talking about a exponential growth question, which would be one of these kind of graphs. I can give you a way to know for sure which kind they're giving you. If they give you a limit to the population, if they say the most bees that can live in this field would be this, they're talking about this kind of graph. And if they don't give you a limit, they can't be talking about that kind of graph. Because this kind of graph, you have to be given this top number. You can't determine that top number, at least with any methods that we teach. Okay? So bottom line is, look for that. If they tell you a limit, the highest that you can have is this, then you're talking about this kind of graph, and you should use the y equals the limit over 1 plus a b to the x, that whole thing. But if they're talking about the 2 points, like this is year 1, or sorry, year 0 actually, and then this is the next year, and this went with this and this. You're giving you 2 points. It must be one of these kind. All right. Now, is this growth or decay? This bird's one. It's decay. All right. Would still work exactly the same way. You just solve for b, and just when you're done, you get b. It ends up being like 0.83 or whatever. Okay. One last thing. Do you remember on these that you cannot use a 2010 right there? What has to be right there? A 0. And if this is a 0, you have to think back and say, well, it was 2010, and so this would become a 5. And then you use those points. 0 goes with this. That's a start value. And then this is your x, and this is your y. See what I'm talking about? To go into your other equation. All right. So this kind of application question, given the population equation is this, they've told you that there's only so many zebras or whatever can live there. And I hope you could answer all of these. The y-intercept, which is the starting value, the range, continuity, maximum. Are there any of these that you would not be able to answer or need clarification on? Oh, one thing, symmetry. We are not going to ask you to calculate the point of symmetry. Like you could say that there's symmetry around that point, but it gets complicated and we're not messing with that. Yes? Yep. Yep. Good point. It is a dotted line here, so you're right. It would never actually get to this. So you'd say the range is between 0 and 350 with parentheses. Okay? Good question. Anything else you want to know about that? Are these kind always bounded? Yes, they are. They're bounded above and below. They're stuck in that range. Okay. One more concept that you learned about in higher algebra, but you haven't done in a while, is this. And the reason I'm bringing it up is because you kind of need to know how to do this. I'm not just trying to do a fun little review moment. So if these had the same base, it would look like this. Like 2 to the x equals 2 to the 7. And then, duh, what's x got to be? X got to be 7. If the base is the same, it's super easy. But if they're not, you have to make them the same. Well, how do I do that? Well, 2 to the x could be written so that there is a 2 here. And then it's got to be to the 6th. But it'd be 2 to the something. So I'm replacing my 4 with a 2 to the something. Do you get what I just did there? So it's got to be 2 to the what? 2 to the 2nd. So just wait a second. This has to be a 2. So it's 2 to the 2. And then that's all put to the 6th. And so now they have the same base. And now this has to equal those two together. And so therefore x would be 12. You get that? Use that same concept. Figure out that one for me. Don't say it, write it. Engage that part of your brain. It's a different part. So 3 to the x is equal to, this 9 could be written, help me, 3 squared to the 5th. X would equal 10. Raise your hand if you got that one right. Okay, good. That was the easy kind. Now let's move up to the high school level. I seriously could have taught that to 7th graders. You guys can figure this one out. It's the same idea. Just a little more stretch at the end to figure out what to do. Just in case this holds you up, 4 to the 3rd is 64. So that, I don't mean that to be the tricky thing. So this is really 4 to the 3rd to the x equals 4 squared. Now some people that don't like to write things down, I think once you write it down, it'll become so much easier. Like once you see that, you can go, okay, well then the bases are the same, so that's got to be the same as that. And hopefully you'll be able to do this last little leap. If 3x has to be the same as 2, isn't that exactly like saying 3x equals 2? And therefore x must equal 2/3? Raise your hand if you could follow what I just did there. All right, some of you are not able to follow it. Let me help you. If I've got my bases the same, then this little bubble has to equal that bubble. So just set it equal in an equation. 3x has to equal 2. Once you've got this, you solve that little equation by dividing by 3 on both sides. And x equals 2/3. That's all there is to it. All right, one more like that. High school level, you might say. 4 to the x equals 16 to the 3rd. Solve it. This is what we do for solving ones where we're not ready to break into logs yet. When they are ugly decimals or you can't make the bases the same, then you have to use logs. So, oh, that's right, you want to take this. Okay, so here's what I hope you did. I hope you said 4 is going to be the common base, so I'm going to write this as 4 squared, and then that's to the 3rd, and so what's the big deal? It's x equals 6. Yeah, that's it. Raise your hand if you had 6. Good. This x must be 2 times 3 is 6. All right. Half-life and doubling problems, the last kind of problem. And the cool thing is that you can make this just like one of the other problems that I've already showed you how to do. Say there's 10 people that occupy Wall Street, and it doubles every 5 days. I could see somebody in the news saying something like that. Started out with 10 people, and it's been doubling about every week, or doubling about every 5 days. Well, then couldn't you make like a little list for yourself and say on day 0 there was 10 people, and then on day 5 there was 20 people? And in effect, you've just turned it into one of those problems where you got 2 points, right? Know what I mean? I could use 0, 10 is my starting value. Y equals a, b to the x, and the starting value goes there, so I stick a 10 there. And then I could stick in this for x and this for y, 5 and 20, and solve for b, and I can do it that way. Raise your hand if you get that. You get that? Okay, good. Then let me show you a shortcut that's really nice. Really nice. Okay, let's get rid of this for a second. Here's the answer that you get. After you do all the work, it's a kind of a bit of a pain in the butt. Do all the work and you'll end up getting this answer. Could you just look at the problem and see how you could have got that answer right off the bat? Do you get how this 10 shows up there? Starting value. They told you the starting value, so now that's 10. Doubling. See how that's a 2? The only thing that's a little tricky is the every 5 days part, and it's hard to understand why this works, but it does. You just put how many days as the bottom part of the fraction. I could prove this to you by just using this point and plugging in the numbers and solving it, and I would end up at the very end, I'd have b equals 2 to the 1/5 power, and then you could get some decimal for that, or you could just see that here's the 2 and this is to the 1/5 power. See, there's a 1 right there, really? Okay, so either you can do it the hard way, which actually is not that hard, it's just make 2 points, do the same process we always did, or you can do it the easy way, which is memorize this little formula. And then if I change it to like, you've got 100 donkeys. They're tripling every 7 days. Bing, I got my answer. See what I'm saying? All right, so I'm going to make one like that. See if that's stuck in your head long enough. You've got 7 amoeba in the dish. They're going to quadruple every week. What's the formula? Seven quadrupling every week. Don't put over 1. Put over what? Raise your hand if you had that right. And you know an awesome shortcut. Okay. that's the stuff you need to know for tonight. Tonight's homework is page 296, 1 to 22, 296, 1 through 22. And we have about 5 minutes left, which is perfect. I'm going to take scores from today's homework.